Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss upcoming videos, subscribe to the channel and activate the notification bell to receive all updates. And what if, right now, as you read these words, on the other side of the sun, there existed an entire planet identical to Earth, invisible to our eyes only because it's always hidden from our view? A mirror world, in perfect orbital opposition, that has traveled with us for billions of years, but no one has ever directly observed. The idea may seem like something out of a science fiction novel or a visionary graphic novel, but it's a concept with ancient roots, grounded in Greek philosophy and even woven into modern scientific hypotheses. This hypothetical planet has an evocative name, Counter-Earth. A term that ignites the imagination but also raises deep and fascinating questions about our solar system, celestial balance, and the still unexplored possibilities of the universe. And what if this planet were inhabited? What if a parallel civilization, evolved in perfect sync with ours, was looking into space at this very moment, asking itself the same questions? And if, in some distant future, technology allowed us to reach this hidden counterpart? Strange as it may sound, this story begins in ancient Greece, within the Pythagorean school. Philolaus, one of the greatest philosophers of that movement, who lived in the 5th century BCE, posed a fundamental question. Why does the sun rise and set every day? Today we take the answer for granted, but back then, without any knowledge of the Earth's actual shape, its rotation, or its motion around the sun, providing an explanation was anything but simple. And yet, Philolaus tackled the problem with a surprisingly scientific mindset, constructing a model of the cosmos that could make sense of what he observed. This model was neither geocentric nor heliocentric. At the center of the universe, according to him, was neither the Earth nor the sun, but a mysterious, central fire, which he called Hestia, later renamed Vesta by the Romans. All celestial bodies, including Earth, orbited this invisible fire. In this scheme, Earth completed a revolution around the fire in 24 hours, thus explaining the alternation of day and night. Even though today we know reality is quite different, Philolaus's idea worked surprisingly well to explain the apparent motion of the sun. But there's an even more curious detail. In his system, Philolaus included another planet, a mirror Earth placed on Earth's orbit but on the opposite side of the central fire. He called it Counter-Earth. This imaginary planet was exactly 180 degrees away from Earth, always hidden from our view, concealed by the sun. And here begins our exploration. Could such a planet, similar to our own, really exist without us having discovered it yet because it is perfectly hidden? In the modern solar system, with the sun at the center and the Earth orbiting it in an ellipse, the only way such a planet could remain hidden would be to position it in one of the Lagrangian points, specifically point L3. Lagrangian points are 5 regions in space where the gravity of the sun and Earth perfectly balance, allowing an object to remain there in equilibrium. L3 is the point located directly behind the sun, opposite Earth, making it theoretically invisible to our telescopes. However, the matter is more complex. Among the 5 Lagrangian points, only the 4th, L4, and 5th, L5, are stable equilibrium points. In fact, these are often where Trojan asteroids are found, like in the case of Jupiter, which hosts entire families of objects in L4 and L5. The other 3 points, L1, L2, and L3, are unstable. An object placed there, even with minimal disturbance, would be pushed away over time, moving from its initial position. Nevertheless, L3 remains the most intuitive location for a hypothetical counter-Earth, because it would be perfectly hidden from our view. But things get even more complicated when we consider the so-called three-body problem. Lagrangian points work perfectly only in a simplified version of this problem, where the third body, such as an asteroid or probe, has negligible mass compared to the other two. If the third body were a planet with mass comparable to Earth, the the conditions would radically change. In this case, the balance of point L3 would be easily destabilized even by small gravitational influences from other planets like Venus or Mars. The result would be that counter-Earth would end up leaving its hidden orbit, becoming visible, or even colliding with Earth or the Sun. An interesting study, dating back to 1968 and conducted by American researcher Riord Duncombe at the U.S. Naval Observatory in Washington, explored this possibility through a simulation on one of the early computers of the time, an IBM 360. Duncombe imagined a planet called Clyon, positioned at point L3, and simulated its orbit for 112 years. No matter the initial parameters, the simulation showed that Clyon always ended up becoming visible from Earth and significantly affected the orbits of the other planets, especially ours. Such a planet, if it truly existed, would therefore have measurable gravitational effects. But none of the probes or observations ever detected anomalies of this kind. In fact, today we're even capable of observing the space behind the Sun thanks to probes like Stereo, a pair of spacecraft designed to provide a stereoscopic view of the Sun. One of the probes moves slightly faster than Earth, the other slower, to cover different angles of our star. Over time, this configuration has allowed us to observe the entire solar disk, including regions we never normally see from Earth. If there really were a planet-sized body hidden there, these probes would surely have detected it. And yet, despite the evidence against it, counter-Earth continues to fascinate. It's a concept that refuses to disappear. It reappears in novels, films, comics, TV series, as the archetype of an otherworld, inaccessible, but deeply connected to our own. A mysterious double, a cosmic reflection, a gravitational shadow that watches us without being seen. It is a symbol of all the possibilities science has yet to confirm, but also hasn't completely ruled out. And it presents us with an even bigger question. How much do we really know about the universe we live in? If our understanding of the universe is only partial, if we're missing fundamental details because we're bound to our point of view, could there really be something enormous, even close to us, that has completely escaped our notice? After all, the universe is vast, silent, and dangerously skilled at hiding its secrets. Counter-Earth is one of those mysteries that invites us, once again, to never stop looking up at the sky with curiosity and wonder.